Hello everyone, this is Dharamvi sir here. So today we are going to start chapter 7 of grade 11 maths, which is permutations and combinations. And the topic of today's video is fundamental principle of counting and the meaning of factorials. So let's start. So coming to the fundamental principle of counting, which is also called multiplication principle. So suppose we have an event E which can occur in m different ways, and associated with each way of E there is some another event F that can occur in n different ways. Then the total number of occurrence, that in how many ways the event E and F occur, will be given by m multiplied by n. And don't forget the order, it should be m multiplied by n. Okay, so we have E m times, following which we have F n times. Then the total number of occurrence of the two events in the same order will be m multiplied by n. This principle is called multiplication principle or the fundamental principle of counting. Now coming to one more very important principle, that is called addition principle. So again, if we have an event E which can occur in m ways and another event F which can occur in n ways, and suppose that both the events cannot occur together, E will occur separately and F will happen separately, then E or F can occur in m plus n ways. E or F can occur in m plus n ways. This principle is called addition principle. Clear? So pause and note down these points. So coming to factorials, what is factorial? The notation n factorial represents the product of first n natural numbers. That is, the product on 1 multiplied by 2 multiplied by 3 up to n is denoted as n factorial. And we read it as n factorial. Thus, n factorial will be equal to what? 1, 2, 3 up to n. Multiplication of all the natural numbers up to n. Clear? So suppose we have to find the factorial 5. It will simply means 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So product of first 5 natural numbers. Clear? One very important point, that factorial n can be written as n into n minus 1 factorial, which further can be written as n into n minus 1 into n minus 2 factorial, which can also be written as n into n minus 1, n minus 2, n minus 3 factorial, and so on. Remember this property because we will use this in many sums. Okay, so pause and note down these points. So let's start exercise 7.1. And the question 1 is, how many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that first is repetition of the digits is allowed and the second is repetition of the digits is not allowed. So first case, repetition is allowed. So we have the digits 1, 2, 3, 4, 5. So units place can be filled, since we are forming 3 digits. So unit place can be filled in 5 ways. Since the repetition is allowed, so the tens place can also be filled in 5 ways. And for the same reason, the 100 place can also be filled in 5 ways. So using the multiplication principle, the total number of 3-digit numbers will be 5 multiplied by 5 multiplied by 5, that is 125. Clear? So pause and note down the solution. Coming to the second part, that is repetition of the digits is not allowed. Now since the repetition is not allowed, so units place can be filled in 5 different ways by any of these digits, but the tens place can be only filled with the remaining 4, any one of the 4. And in the same way, the 100 place can be filled with any one of the remaining 3. So again, using the fundamental principle of counting or the multiplication principle, the total number of 3-digit numbers will be 5 multiplied by 4 multiplied by 3, which is 60. Therefore the required number is 60. Clear? So pause and note down the solution. Moving to question 2. How many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5 and 6 if the digits can be repeated? Now here we have to form only the even numbers. Even means that at unit place only 2, 4 and 6 can be there. So number of digits, possible digits for the units place will be 3, because only 2, 4, 6 can be there. Now unit place will be filled up any one of the 2, 4 or 6. But in the tens place, we can fill any of these 6 digits because repetition is allowed. The digits possible at the tens place will be 6. And in the same way, the 100th place can be filled by any one of the 6 digits, because again the repetition is allowed. So again, using the multiplication principle, or also called the fundamental principle of counting, the required number of 3-digit even numbers that can be formed using 1, 2, 3, 4, 5, 6 will be 3 multiplied by 6 multiplied by 6, which is equal to 108. Clear? So pause and note down the solution. Next we have question 4. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appears more than once? Now as you can see in the box, the first 2 digits are fixed, 6 and 7. We need to find the remaining 3. Now it is given that the no digits appear more than once, so digits are not repeated. So out of the 10 digits 0 to 9, 2 are fixed, so we have remaining 8 digits that can be in the remaining 3 places. So first box can be filled in 8 ways, second will be filled by the remaining 7, any one of the remaining 7, and the third can be filled in any one of the remaining 6. So again, using the fundamental principle of counting or the multiplication principle, the total number of 5-digit telephone numbers using the digits 0 to 9 starting with 67 will be equal to 8 multiplied by 7 multiplied by 6, which is equal to 336. Clear? So pause and note down the solution. Moving to question 6, we have given 5 flags of different colors. How many different signals can be generated if each signal requires the use of 2 flags, one below the other? Now as in the box you can see that we have 2 different boxes, one below the other. Now we have 5 colors, 5 flags of different colors, and we need to use only 2. So first place can be filled with any of these 5 colored flags. So if you use one flag for the first position, then the number of flags remaining for the second will be 4. So again, using the fundamental principle of counting or the multiplication principle, the different codes that can be formed with be 5 into 4, which is 20. Clear? So pause and note down the solution. So let's start exercise 7.2, and the question 1 is evaluate factorial 8, or second is factorial 4 minus factorial 3. So first, factorial 8 means what? The product of the first 8 natural numbers, that is 1 into 2 into 3, 4, 5, 6, 7 up to 8, and the product will be equal to 40,320, 40 through to 0, simple. And the second one is we have to find factorial 4 minus factorial 3. So factorial 4 equals to what? 1, 2, 3, 1 multiplied by 2 multiplied by 3 multiplied by 4 minus, and factorial 3 is equal to what? 1 into 2 into 3. So simplifying, we get 24 minus 6, which is equal to 18. That's it. So pause and note down the solution. Next is question 2. Is factorial 3 plus factorial 4 equals to factorial 7? We have to check whether this is possible or not. So let's find factorial 3 plus factorial 4. Now factorial 3 is equal to 1 multiplied by 2 multiplied by 3. And factorial 4 equals to 1 into 2 into 3 into 4, which is equal to 6 plus 24, that is 30. Coming to factorial 7, which is equal to the product of first 7 natural numbers, 1 into 2 into 3 into 4 into 5 into 6 into 7, which is equal to 5040. Now it is clear that 30 cannot be equal to 5040. Therefore factorial 3 plus factorial 4 cannot be equal to factorial 7. Clear? So pause and note down the solution. Moving to question 4. If 1 upon factorial 6 plus 1 upon factorial 7 equals to x upon factorial 8, we have to find x. So multiplying the entire equation by factorial 8, the largest factorial, so we get factorial 8 upon factorial 6 plus factorial 8 upon factorial 7 equals to x. Now using the property n factorial equals to n into n minus 1 factorial, we get factorial 8 equals to what? 8 into 7 into factorial 6 upon factorial 6 plus same factorial 8 can be written as 8 into factorial 7 upon factorial 7, which is equal to x. So we got factorial 6 and factorial 6 cancel, and factorial 7 and factorial 7 cancel. We are left with 8 7 is 56 plus 8 equals to x, and this 56 plus 8 equals to what? 64. Therefore the required value of x equals to 64. So which property did we use? It is factorial n equals to n into n minus 1 factorial, or n into n minus 1 into n minus 2 factorial. We used both in this particular sum. Clear? So pause and note down the solution. Moving to question 5. Evaluate factorial n upon factorial n minus r when n equals to 6, r equals to 2 and n equals to 9, r equals to 5. So first one is n equals to 6, r equals to 2. We have factorial n upon factorial n minus r will be equal to factorial 6 upon factorial 6 minus 2. So 6 into 5 into factorial 4 upon factorial 4. Now factorial 6 equals to 6 into 5 into factorial 4. How? Because n factorial can be written as n into n minus 1 into n minus 2 factorial. So using that for factorial 6. Now factorial 4 and factorial 4 are cancelled. So we get 6 5 is 30. So factorial n upon factorial minus r equals to 30 when n equals to 6 and r equals to 2. Coming to the second part. When n equals to 9, r equals to 5. So factorial n upon factorial n minus r will be equal to factorial n upon factorial 9 minus 5. So factorial 9 upon factorial 4. Now using the same property, factorial n equals to n into n minus 1, n minus 2, n minus 3 up to n minus 4, n minus 5, n minus 6 factorial. So factorial 9 can be written as 9 into 8 into 7 into 6 into 5 into factorial 4. Upon factorial 4 is there. So factorial 4 cancelled. We got 15120. Therefore the value of factorial n upon factorial minus r is equal to 15120 when n is equals to 9 and r equals to 5. Clear? So pause and note down the solution. With this we end exercise 7.1 and 7.2. So solve the other sums and don't forget to solve the examples given before both the exercises. Clear? Thank you and all the best.